Good afternoon, all. I hope you can see my slide, currently on the title slide. So it's a great opportunity to present Worley's perspective on the role of technologies, including new technologies, in general across the energy transition, but also in India. Now, the purpose and the insights I'll be sharing is not about a singular technology, but focuses to set the various technologies into perspective of each other, but also into a bigger picture. Well, we all understand how fundamental technology is to enable the energy transition, but the uncomfortable truth, or what is a bit more uncomfortable to admit, is just understanding the technology by the commercial and technical readiness is actually not enough. The reality and the complexity on how to deliver the projects at the scale and speed we need to meet net zero is way more complicated. So, and that's the theme for today. It's to actually weaving the different threats needed, and technology is one of them, to make it real and meet net zero. Worley collaborated with Princeton University, and we asked ourselves, how do we make the transition to net zero real? The what is pretty much understood. The dynamics of climate change is also understood. If you look at the latest report from the Intergovernmental Panel on Climate Change, you realize the magnitude and the urgency of action. Now, to achieve mid-century net zero ambitions will require pace and scale of delivery of engineered solutions that is unprecedented in global terms. Now, there's been a lot of great thinking in that space, but what's been the missing piece and what's been the focus of working with Princeton University is actually around the infrastructure and the role of technology in it. To give you a sense of the size of the challenge we are confronted with, and this has been presented at the Hydrogen Congress last year, if we meet net zero by 2050, we would need to build the largest carbon capture and storage project currently running every week from now until 2050. We would need to build the largest solar plant ever built every 3 days, or every 2 hours, we would need to build the largest green hydrogen project built ever, every 2 hours. So that's kind of just an indication of the size of the challenge we are confronted with, and it almost makes it unreal. So, in order to make it real, we need to reimagine how big projects are delivered. Business and governments across the world must step up to engage, design, and build. And if we don't, we will simply not reach the emissions reduction targets. Now, what this graph actually says is that the best policy in the world in isolation will not lead to the impact desired. There is a need to change delivering practices of large projects in tandem with appropriate policies to have that material impact. Now, the bigger picture is however, a bit more complicated, and there's been significant effort to actually map these out and map out the dynamics around that. There are numerous elements influencing outcomes, and the net zero infrastructure supply side is dependent on many things, and it's highly complex. The easy bit is to understand the technology. It's there. We do studies to understand the readiness levels. The gaps to the commercial applications is actually also quite easy to understand. But let's look at all these other threats which are needed to be considered to make it work. The raw materials, or the demand side, or the supporting infrastructure, from mining and manufacturing to cloud hardware to security. This is all what needs to be considered when we look at the technologies at play to make a net zero happen. Now, the research done is actually quite long, and I'll be happy to share the link to the actual paper in the chat box later on. But going a bit fast forward, what's the key findings? What do we need to do differently? So there needs to be a different understanding of value. We need to look at this away from a pure economic and commercial perspective, but towards a socio-economic and environmental perspective. This is a single opportunity we have for the humanity to include future generations and ensure future resources of our planets are made available and risks are mitigated, risk of extreme weather are mitigated. Now, also the role of digital is absolutely huge and a key enabler. Key partnerships, we need to rethink, and we as Worley, we actually see how stakeholders around major projects, they actually engage with each other differently. And that is brilliant to see, yet it just needs to increase in pace and scale and needs to be replicated. Now, what is very important in this is that an acknowledgement that there is not a one solution for all. And I think that holds very much true for India as well. There is this paradigm, it's like, well, let's just do this or let's just do that. The reality is that there's so many unknowns, there's so much uncertainty across that one cannot just take a decision which is a right decision. One needs to, at this point of time, consider and look at all different technologies, all different ways to start moving into that direction. And therefore, from a business perspective, it's a lot about actually risk management and understanding where to place the bets and where to make the efforts, where most likely there is success. But that's, again, extremely difficult. Now, every country will have its own mix of technology solutions. Now, a lot of eyes at the moment are on Europe, and that's actually a good example to learn from. Yet, every country has its own predisposed resources and circumstances, or even in the case of India, every state is different, and that has to be considered into which technologies may actually have the best opportunity to grow and scale. There is significant cost savings with an approach which standardizes, modularizes, and digitizes. And we think that India actually is uniquely and very well placed to take advantage of that, together with a very tech-savvy young population. Now, I said already, technology solutions and their maturity level are well understood, and this slide actually does summarize it. Now we understand this is a very simplified slide. So behind bioenergy and other zero carbon fuels and feedstocks, there are many sub-technologies. So this is a bit of a simplified picture, but gives an idea of which technology is commercially viable right now, which we see is deployed, and which point will be. Just conscious of time, so I'll move on. Of course, I'll be happy to take questions later on. Now, we as Worley, we engage at the forefront of energy transition in India, and this is based on our own research. We kind of mapped out the trajectory, and when my team shared this with me, I was simply impressed by the opportunity India presents, but also the steps taken, the commitments in terms of funding and change of standards, which trigger a demand for cleaner fuels, is happening. So this is real. So this is based on our research, but we also acknowledge that things change really fast. Now, we can look back at the global level to have completed or in completion, we are in completion of more than 3,000 projects, and therefore in a position to take really a cross technology view on what may be suitable or not, and when to make net zero real. And to make it a bit real for you, I just want to showcase 2 projects which we are involved. The first one is a company called Liquid Wind, and they have announced to build a first facility in Sweden. They use CO2 from a biomass-fired power plant, and they use green hydrogen to produce e-methanol with an accessible scale-up timeline. So at the moment, they're looking at the pilot. Then in sometimes they look at 10, and then the second stage is 500 facilities globally. This is very promising, and the reason why I'm showing this example is we believe there is relevance for India in this. The second project I'd like to highlight, and goes well with the theme on refining, or the focus on refining today, is Shell's Holland Hydrogen project. It's located in Rotterdam, and the operations are scheduled to start in 2023, and it's gonna produce 50 to 60,000 kilograms of hydrogen per day. Overall capacity will be 200 megawatt. Now, I'm showing this because the aim of Shell is to use this in its refinery in Pernis to particularly decarbonize the production of fossil fuels, and to support the industrial use of hydrogen in the heavy transportation industry. Now, I want to close my presentation just by saying and reinforcing that by coming together now, we intelligently can bring innovative solutions together and foster new ones. So I urge each one of you to be that advocate of a sustainable future, and within your sphere of influence. It's together that when we can make a lasting impact happen. Thank you.